All right, this next one is a good example of why I want us to learn limiting reactant the exact way that I taught you. Um, because we're going to divide by coefficients here without actually running, quote unquote, running the reaction. So the first one says, using the equation above, what is the limiting reactant if given 71 moles of aluminum and 13.5 moles of S8? And if given our react, I kind of wrote that weird, I'm sorry, but let's pretend that I wrote it the right way. Okay, so what we would need to do is, there's a way that I haven't said this before. I'll say it now. Maybe it'll make more sense. So if we have 71 moles of aluminum, I've got 71 moles of aluminum. One way I guess we could look at it is this equation is telling us that we need 16 moles of aluminum for every one reaction, right? So if I were to follow the pattern that I had before of multiplying this by a fraction, I need 16 moles of aluminum for every one reaction that I run. So how many reactions can I run with 71 moles of aluminum? Let's calculate that out. So 71 divided by 16, that's going to give me 4.4375. So I can get 4.4375 reactions, right? Like before we had said this number doesn't really have a unit, but that's how many reactions I could get out of that. So let's see if we have 13.5 moles of S8, of S8 times, okay, so what's the coefficient here? 3. So what we're saying is for every 3 moles of S8, I can get 1 reaction done if everything else was perfect. All right, let's calculate that out. 4.5. 4.5 reactions. Very close, actually. So what does this mean? Well, this is kind of like that thing where it's like, oh, if I've got 50 slices of bread and 5 slices of cheese, how many sandwiches can I make? Well, with 50 slices, I can make 25 sandwiches, but I'm going to run out of cheese way before I get there, right? So whichever one is the smaller number here, that's the smaller number, meaning I'm going to run out of aluminum first. It doesn't matter. This is a fake number. I'm never going to get to 4.5. So my limiting reactant is aluminum. Next part. How many moles of Al2S3, that's this one, are produced if 71 moles of aluminum are reacted with 13.5 moles of S8? So it's the same numbers. Notice it's the same numbers. So that means we can use the numbers that we've already gotten up here, kind of, I guess. So let's see, we'll start out with 71 moles of aluminum. We can ignore the 13.5 moles of S8 because it's in excess. We won't use it all. And I got to multiply by a fraction. What fraction am I going to multiply? Well, I'm trying to go from moles of aluminum to moles of aluminum sulfide, right? So for sure, right down here, I'm going to put moles of aluminum. And then on top, what am I trying to get to? Because here this cancels out, right? What am I trying to get to? I'm trying to get to moles of aluminum sulfide. Anytime I have moles over moles, I'm going to use these coefficients from the balanced chemical equation, 16, 8, right? I'm just using those numbers right there. And that's how many moles of Al2S3 I'm going to get. So I'll calculate that out. I'll spare you guys this time. 71 times 8 over 16 is going to give me 35.5. So I'm going to get 35.5 moles of Al2S3, right? That 13 whatever was extraneous. All right, last one. How many moles of aluminum are needed to completely react with 33 moles of S8? Now, I noticed some of us having trouble with this when we did the assignment because I'm only talking about reactants. And we kind of got used to comparing a reactant to a product, but it doesn't matter. If there's a coefficient in front of it, then there's a ratio to it. If there's a ratio to it, you just work it out the exact same way. All right, so here we're given 33 moles of S8. Cool. I'm definitely going, if I'm converting, right, I need to convert to moles of aluminum. I'm definitely going to multiply by a fraction. What goes on the bottom of my fraction? Whatever this is right here. So moles of S8. And then what goes on the top of my fraction? Well, moles of aluminum, because I can convert directly. I can compare them directly. Cool. All right. Anytime I have moles of one thing over moles of another thing, I'm going to use the numbers from my balanced chemical equation. S8 is 3, aluminum is 16. Now, if this is confusing to you, like how could we put these numbers? How does this make any sense? What I'm saying is I have 33 moles of S8, and for every 3 moles of S8 I use in a reaction, I need 16 moles of aluminum. Like for every 1 slice of cheese, I need 2 slices of bread, right? So that I can make this product. So how many slices of bread do I need? How many moles of aluminum? I calculate this out. Again, 33 times 16 over 3. And I'm going to get 176 moles of aluminum. And that number makes sense, right? 33 to 176. That number makes sense.